open up your phone, type out a quick thought, and hit post. A second later, your text pops up on the screen, ready for the world to see. Behind that simple tap, hundreds of millions of people are doing the exact same thing every single day. The system catches and routes thousands of new messages every second without skipping a single beat. To pull this off, the platform functions as a massive global newsroom running at hyperspeed. In this setup, you are the user. Whenever you hit post, you are submitting a breaking story straight to the newsroom's intake desk. Understanding how this newsroom is built shows us exactly how engineers keep massive, crowded networks from collapsing under the weight of their own traffic. The moment your story hits the intake desk, it is handed off to an intake writer. We are looking at a diagram of the very first thing that intake writer does. It takes your single message and instantly clones it, sending the two copies down different paths to solve two very different problems. The first copy travels down this lower path into a permanent memory database. This guarantees your message is safely recorded in history and won't be lost if the server loses power. The second copy travels up to a fast assistant cache. This keeps your message readily available, so anyone who wants to read it right now can grab it instantly without having to dig down into the main database. Once your message is secured by both the memory database and the fast assistant cache, it gets placed into a high-speed digital queue, waiting to be shipped out to your audience. By splitting the slow job of recording data from the fast job of getting the news out, your phone is freed up immediately. You never have to stare at a frozen screen waiting for the heavy background processing to finish. Now, your message sitting in that digital queue reaches the news editor. This editor has one highly specific job: figuring out exactly which timelines need to see your new post. In the push model, a node actively fires a message to all followers simultaneously. This bottlenecks for celebrities. To prevent meltdown, the pull model simply pins a single copy to a central server. Your device then reaches out and pulls a copy when needed. The platform switches between these two methods based on who is posting. It sends small updates instantly, but waits for people to ask for the massive ones to save server power. There is still one last piece of the puzzle. You might notice that when you are reading your feed, new messages will pop up on your screen, even if you don't swipe down to refresh the page. This happens because of a persistent connection between the server and your phone, streaming new data instantly. In older systems, your phone must manually knock and request updates before the server briefly responds. When you look at the whole picture, it is a perfectly synchronized distributed system. The intake writer catches your words, securing them in the database and on the fast cache. The news editor decides whether to push or pull your story, and that persistent connection streams the final result to the audience. That tiny tap on your screen triggers a massive, carefully designed engine that flawlessly routes information across the globe in milliseconds. In our next breakdown, we will map out the specific architecture that powers video updates on WhatsApp statuses. See you there.